So we will understand the construction of the Mohr circle through an example. So let us consider a two-dimensional stress element. The two-dimensional element subjected to a sigma x, that is normal stress acting in x direction, and again a normal stress acting in y direction. So both are tensile in nature, and it is subjected to the shear stress acting in all the planes. So like this, so tau xy is the shear stress. So in order to draw the Mohr circle diagram, we need to find out the coordinates of x phase and y phase. The coordinates means the stresses acting on the x phase and y phase. So here I have written, consider this as x phase, and this phase is considered as y phase. So the stresses acting on x phase are sigma x and tau xy. The stresses acting on y phase are sigma y and tau xy. So you know the sign convention for the normal stress. If the stress is acting away from the body, which is considered as tensile, and it is positive. If the stress is acting towards the body, it is compressive stress, and the sign convention of that is negative. So positive, negative directly you can take for the normal stresses. But what is the sign convention for the shear stress? That is very important. So this shear stress which is acting in the clockwise direction in this phase, so is considered as positive, and the shear stress acting in this phase is counterclockwise with respect to this. It is counterclockwise, so it is considered as negative. So the clockwise shear stress is considered as positive, and counterclockwise stress is considered as negative. But how do you remember this clockwise shear stress and counterclockwise shear stress? So it is easy to remember if you remember this situation. So in a living hall, so where do you keep the clock? So usually you keep the clock in the wall, that is above, and where do you keep the counter? Usually keep the counter on the table. So wall means above, counter means below. So above is considered as positive, below is considered as negative. So what is this above and below? See, it is with respect to this coordinate system. So above this positive, below this negative. So remember, above positive, below negative. So with respect to that, so this is the clockwise shear stress, above positive. So this is the counterclockwise shear stress, counter below, so negative. So if you write the sign convention of one shear stress, other one will be obviously opposite to it. So if you write one, other one you did not check, straight away you write the opposite sign. So sigma means the x phase coordinates and y phase coordinates are written like this. So now these x phase coordinates and y phase coordinates have to be reproduced onto a Cartesian coordinate system with the proper sign convention. So because the Cartesian coordinate system will have the coordinates to be, for example, this is the first quadrant, all the values here are positive, so we write in the form of plus x and plus y. So this is the second quadrant, this is the second quadrant, so the coordinates in this quadrant will be of the form minus x plus y. So here this is third quadrant, minus x plus y minus x, minus x minus y minus x minus y, and coordinates in the fourth quadrant will be of the form plus x minus y, plus x minus. That means if you remember this sign convention, so you can easily locate these coordinates on a Cartesian coordinate system. So here I have taken first an example, then we will explain once again with the proper example so that the concepts are very clear. So now, so this x coordinates are represented here. So this is what is the sigma x distance, and this is what is tau xy distance. So plus sigma x plus tau xy. So these values are represented here. Initially, what we do is first we locate a point in the Cartesian coordinate system. That means we have located, let us assume that we have located the point x here. Similarly, locate the point y. The point y is here. So y is, this distance is sigma y, and this distance is tau xy. Just locate this point. So after locating the points x and y coordinates, you join them. So draw a line from here to here. So actually the xy is actually the radius of the xy is a diameter of a Mohr circle. So this xy diameter will intersect with the x-axis, that is at point C. Now taking point C as center, Cx as radius, you draw the circle. So after drawing the circle, what you get is a Mohr circle. Okay. Now the intersection of this Mohr circle with x-axis, that is sigma axis, is important. So that will give you the maximum and minimum principal stress. The farthest intersection of the Mohr circle with the x-axis is what is considered as sigma 1. Actually, this point here is sigma 1. So from where to where you will measure? You measure from O to A to the scale. you measure from here to here. Then where is point 2, that is the minimum principal stress. So the nearest intersection to the origin is what is known as the minimum principal stress. Okay, you measure this distance to the scale, you will get sigma 2. Then what is the maximum shear stress? You know, in the previous understanding we understood, previous theory we understood that the radius of the Mohr circle gives you directly the shear stress. That means R is equal to, you recall the previous equation, so R was equal to under the root sigma x minus sigma y by 2 whole square plus tau xy square. So this will directly give the radius of a Mohr circle. So you don't need to worry about this mathematical equation. So directly straight away measure this radius, that will give you tau xy. That means the distance from this to this is actually tau xy. This is tau max actually, not tau xy, maximum shear stress. The distance from here to here is sigma minimum, that is the minimum principal stress. The distance from here to here is sigma maximum, or is also denoted as sigma 1. Most of the cases this is standard notation. This is sigma 2. Okay. So now from this Mohr cycle diagram, we could able to measure the maximum principal stress, the minimum principal stress, the maximum shear stress. Also, it is possible to measure the direction of the the direction of the plane in which the stresses are maximum. So the inclination of the plane. So inclination of the plane will be measured with respect to this xy plane. So usually with respect to point x and the sigma axis, the angle will be measured. So this is the angle. So this plane to the sigma axis. So this 2 theta. So direction will be in which direction, if you rotate the plane x, that will merge with sigma axis. So that is the direction. So here I have written direction, that is clockwise direction. So if you rotate this plane x in the clockwise direction, so this will merge with sigma axis. So that is the direction for the plane where your stresses will be maximum.